We are going to be looking at Chapter 2, Section 2, problem number 30. In this particular problem, it states that the marriage rate per 1,000 unmarried women is given by the following table for the years 1960 to 1997. And so here we have this table that I have reproduced for the years from 1960 to 1997 and the marriage rates per 1,000 unmarried women. The first thing it asks us to do is to write a linear function that models the marriage rate as a function of the year after 1950. To save time, what I have done is I've already entered the information into the calculator, and let me show you what this is. So if I go to the Stat menu and I look at the Edit, you can see that in L1 I have the years 1960, 1970, etc. And this would just go on down, all the way down to 1997. Now, what they have asked us to do is they've asked us to write a function as of the years after 1950. So what I've done is I've made a second column, L2, which is the years after 1950. And so if you take 1960 minus 1950, you get 10 down here. If I take 1991 minus 1950, you get 41, and so forth. In L3, I have the marriage rates that we have over here, and hopefully I have not made any mistakes. What you might want to do at this point is stop the video so that you can enter the information similar to what you now see on the screen. To make our model, what we're going to do is go back to the Stat menu, and we are going to use the calculator function of this, and we are going to do a linear regression. So we are doing a linear regression, and so we'll hit Enter. And what we are going to do, remember that it wanted us to do this for the years after 1950. Well, in my calculator, that's in list 2. And then the marriage rates were in list 3. So this is how I'm going to get the function that they are after. We will now hit Enter. And this here gives us the model that we want. Let me take a moment to write this down. And going to the pin here, and let's see if I can find it on here. Here we go. What we're going to have then is we're going to have the model is going to be y is equal to, and the A number is going to be negative 0.762, and then we're going to have plus, and then we have here 85 point. We have 284. Now, our textbook likes to keep 3 decimal places. I think it's more appropriate to keep 3 significant digits. So if I did it that way, I would have y is equal to negative 0.762. I forgot to put in my x here, so let me insert the x over here as well. And then plus the 85 point, I'd make it 0.3. And so this then is the function that we're going to be using for part B of this problem. Let me rewrite what we had from our model. Our model then is going to be, let's get the calculator a little bit bigger here, okay, and turn it back on. Here we have our model, and so our model is going to be y, and I got to get this set up again. What happens when you forget to make a particular slide? Okay, here we go. Here's our model then. If I can find where my cursor is, here we go. Our model is going to be y is equal to negative 0.762 times the x, and then plus 85.3. And again, as I discussed earlier, I'm going to use 3 significant digits as opposed to 3 decimal places. Let me see, hopefully you can see the decimal point there. Now, what we can do is we can now go into the calculator and try to, okay, see if I can get this on here. All right, here we go. If I go into here, I can put in the answer that we just got for this model. So we had negative 0.762 times the x, and then plus, and we have 85.3. And so this is our model, and we can enter that. Okay. All right. Now let's go to part B of this. Okay. It says, what does the model predict for, and I have a typo in here, this should be 1985, so let's get that typo fixed here. So this should be, cross that off, this should be 1985. Now 1985 is how many years after 1950? Well, if I subtract the 1950 from here, I'm going to get that this is 35 years. And so for this part of the problem, we want to take 35 years and put it into here. Let's use our calculator to do this. Okay? On the calculator, we can get back to the home screen and remember what our model is here. Let me rewrite that quick so that we don't forget what that is. So we have y is equal to, and this thing, okay, let's try that again. So I have y is equal to negative 0.762x, and then we have plus 85.3. Now what we're going to do is take the 35 and substitute it in here. So let's get to the home screen here. And here we go. Click and clear this out. I want to get to the home screen. No, I'm not getting there. Let me use this one. Let's do quit. Okay? And clear. So what we're going to do is we're going to take negative 0.762 times, in this case 35 because that's our x value, plus the 85.3 we said. So if we hit enter, we have an answer of about 58.63. So our answer here is approximately equal to 58.63, or about 58.6 if we keep 3 significant digits. Okay. Now the next part is going to be a little more difficult. It asks, for what year does the model predict that we have a rate of 50 per 1,000? And so what we want to do this time is we want to take an equation. Let me see if we can get here. We're going to have that the y value is going to be equal to, let me start over, going to be 50, and we want to solve for the x. So that's negative 0.762 times the x plus the 85.3. So if I subtract 85.3 from both sides, my penmanship's not too good. Let's write the result over here. Okay? And here we go. 50 minus 85.5 is going to be negative 35.3. And that's equal then to the negative 0.762 times the x. Now on the calculator, let's do this computation. So I'm going to take down over here negative 35.3 divided by a negative 0.762. If we hit enter, we got an answer of about 46. And so this is 46, but remember, this is 46 years after 1950. So if I want the year, I have to add the 1950 to this. And again, my penmanship is poor, but hopefully you can see that we're going to get about 1996. If we had the 0.3 in here, we can maybe say it's 1997. That's our textbook answer, but I think 1996 is a little bit better. Finally, it says, discuss the reliability of your answer for Part C. Again, I have a little typo here, but let's look at what we had for our stats here again. Let me do this here. Oops, wrong thing. And if we scroll down from here, we can get to where does it go below? Well, it went below in 1996. And so that's not too bad, okay? We did not expect to get an exact answer to match the data, but we have an approximate answer, and this now completes this exercise.